Live from Savannah, from Dr. Coffee Live, our first the Coffee Times edition of 2018, and I'm so happy to be back here and talking to you guys, and I hope you guys enjoy watching my videos. And of course, I wish to everybody a wonderful new year. You know, when the new year comes, always comes a lot of ideas and wishes and hope to things get better, and that's what I wish to all of you. And today I decided to do a little bit different than what I've been doing. Like I said, this is a number 8 live video that we do, and I found that it will be good to start the year for let you understand why I'm talking so much about coffee and what I do, and so that was not clear, I believe, to most of you. So I came to US to do my doctoral degree in pharmaceutical science, and when I came to work in the lab, and my idea was to get better in drug monitoring, because that was back in the late 90s was the big thing in pharmacy. But things like everything in life, you plan some things to go one way and they go other way around. And today I'm so happy that things changed to me. That the reason is because the professor that I came to work with, he couldn't stay with me in the lab because he was moving to another facility. And because I had time to finish the doctor program, I couldn't wait for him to do the moving. So what I did was I have to look for another advisor. And then came across of this person, Dr. Murali Ramanathan, University of Buffalo in New York. And he was doing a study with multiple sclerosis in patients with relapsing remitting form of the disease, which is the most common form of the disease, and patients that are with this disease that are treated with interferon beta. And the way he was looking to the effect of the drug in the disease was looking at alterations in the gene, the transcription of some specific proteins, and seeing how this affected the treatment. So for me to be able to join his lab, I had to learn from scratch everything related with molecular biology. And at that time, my genetics was really almost nothing, because everything was new. In 2000, when I joined the program in 1999, and it's exactly in 2000, that was when the genome was disclosed, the human genome. And that was a huge effort between many labs around the world that managed to get all the sequence of our DNA, the human DNA. And so I have to learn how to identify a gene, all the techniques, and so it was really, really important. And why it was important? Because after the genome has been disclosed, most of the research nowadays has always something related with changes in the genetics related with the treatment, with the disease. Everything you read has some genetics or genomic study involved. So being able to know all that and learn all that about, and with people that was very knowledgeable of this topic, so that for me was a big plus. So when I graduated, and then I joined back, like I told you, the group that I was working previously in Brazil, on coffee, I wanted to use this knowledge that I learned in genomics in the coffee project. So initially I was just doing chemistry. I was looking at amounts of chlorogenic acids and caffeine, like I told you, the two most important components of coffee in terms of health benefits. And that was where I started. But then at some point I started seeing so many people, I mean, not many people, but seeing that some people had problems drinking coffee. I mean, they would complain of different things. And I was thinking, what makes the majority of people enjoy coffee, have no problem whatsoever. Some even drink much more than 3 or 4 cups a day. That's what I recommend. Some people actually drink 8, 9, 10 cups a day. And they don't have any problem with that. So I was thinking, why some people have problems? Why, what's going on? Is there a problem in the coffee? Then I was reading, and that's where comes all this talking that I've been doing about coffee, is because in order for you to be able to study coffee, like I want to study, you need to know as much as you can about what coffee does of good and bad, and try to be updated with all the new papers that come talking about it. So part of my day is doing that, is getting those papers, getting them, read them, and try to be updated with that information. And I feel that it's important to share that information with you. But today, like I said, I want to tell you what is my big goal right now in terms of research. So I left a little bit this chemistry thing aside, not only because it was something that I was having some issues in terms of equipment in my lab, so that was kind of delaying to get the data that I wanted, but also because I wanted to do things that could have some practical application almost immediately. And of course, I want to work with humans. I didn't want to be working with just with a coffee brew. I wanted to work with biological fluids from human that consumes coffee and see what happens inside our body after you drink that coffee. Okay, so I start thinking that those people that have problem drinking coffee could be because I read that caffeine, which is most likely the component that was giving problems to those people, because like I told you before, caffeine has some effects in the cardiovascular system, has effects on the central nervous system like the alertness, the increase of memory and all that. But if you have much caffeine, you might have those effects exacerbated, and you don't want that. You just want the good effects. You don't want toxic effects, right? So I was thinking maybe those people that have problem, they might be getting more caffeine than they need. And in reading, I learned that caffeine is metabolized. 95% of caffeine is metabolized by one single enzyme, which is something kind of not very common. Normally, substances are metabolized by different enzymes. But caffeine has this particularity. 95% is metabolized by an enzyme that is called cytochrome P450 of the family 1A2. So, and then I thought, and what happens is that there is part of the population, this is well known nowadays, that has genes that encodes the protein of this enzyme, that instead of being a normal gene, let's say, they have a little bit altered gene. What is this little bit altered gene? It is a gene that has one single piece of it that is changed, is different from the other people. And that tiny change, because most likely occurs in the area where that substance is important to produce its effect, in this case to metabolize caffeine. So if you have that tiny piece of the DNA on that gene that encodes this enzyme change, altered, part of the population has that. And what happens is that instead of metabolizing fast, which is the normal in all of us, those people metabolize slow. So I thought, well, let's imagine, just imagine, that I am a person that has this kind of gene, that has this alteration that makes me metabolize the caffeine from the coffee slower. So what's going to happen? Metabolization normally means to turn the drug or the compound, in this case caffeine, in something that can more easily eliminated by the body. That's the intention of the body when we metabolize something, is to break that down and make that easy to be eliminated. And so what happens if the person metabolizes slower? What's going to happen? The same coffee that I drink, that I have an enzyme that metabolizes fast, and you drink a coffee and you metabolize it slow, so the same amount of caffeine that I'm going to eliminate quickly, you're going to retain longer. And that probably was responsible for the effects that you feel. And then I thought, well, that also is going to be a deterrent for the person to not drink coffee, right? So I said, well, okay, so I'm going to plan a project and test if this is really true. And so I managed to see exactly that. The people who does have a genotype for this specific enzyme that has the allele that has slow metabolization, those people have a higher level of caffeine in the plasma. How I did that, I had a group of students. I offered a breakfast for them, and everybody had the same breakfast. They all came with 8 hours without eating anything. So first thing I did was to collect a blood sample, not myself. I had a person that was knowledgeable on that collected the sample of blood. And then they drank, all of them drank 1 full cup of coffee that I prepared in the lab, that I knew exactly how much caffeine was inside. And then between 30 to 45 minutes later, which is the time the caffeine normally takes to peak in plasma and it starts to be eliminated, we collected another sample of blood and we measured that sample. And we also utilized part of that blood to determine the genotype for the CYP1A2, which is the enzyme that metabolizes caffeine. So, in other words, we found that if you are a slow metabolizer, you're going to build caffeine in the system. And that definitely should be a reason to give those problems that we see in those people. So I was very glad to see that. So parallel to that, it was created worldwide when I was about to publish this paper. And actually, if you go LinkedIn and you look for my name, the paper is there, it is available. It's called "Does CYP1A2 Genotype Can Interfere in Coffee Consumption?" And the reason I made this title was because if you have a slow metabolism of caffeine, that could interfere in your wanting to consume coffee or not, right? So, so this paper is available. You can see with more details if you're interested. But anyway, so when I was about to publish this paper, which was like 3 years ago almost now, and then I noticed that there was just being published a new paper about coffee consumption. Like I told you, I'm always checking the new papers that are coming out. And I noticed that there was formed worldwide a group just to study coffee, caffeine, consumption, and genetics. So I said, wow, this is exactly what I'm doing, right? And see, I mean, I was not connecting with those people, but I managed to be thinking the same thing that a bunch of researchers worldwide were thinking. What they are thinking, that we that drink coffee with no problems and get all those benefits from coffee, we do have a special genome related with coffee consumption that allow us to get the benefits of coffee. Some people doesn't have this genome. So my goal now, my current project, I know is big, but I've been working and about to publish some results already. My current project is entitled "The Fingerprint of Coffee Consumption," meaning that I want to find what are the main changes in our genome that are related with those effects, beneficial and toxic effects of coffee, so that we can know by just having one sample, for instance, from your buccal swab, just a buccal swab, and get your DNA, we can tell you if you are going to have problems or not drinking coffee. So I think that's interesting. And of course, this will also lead to potential targets that could be looked at in terms of new drugs to treat the diseases that coffee protects you against it, like, diabetes we mentioned, like Parkinson's that we talk about, like depressions that we also talk about. So that's my project currently. And so I'm very happy to share that with you. And I want to make a request before I go today, for you to go to my page of the Dr. Coffee Research and Consultancy, and say that you like it, and if you could join and follow, so I can get your email. I want to start getting a list of the emails that all of you that are following my videos, so I can share those papers directly with you. You don't have to go to LinkedIn and things like that. And also, I would like to ask you another thing, is that if you know anybody who works with coffee, doesn't matter what is the field, if the person has a coffee shop, if the person produces packages for coffee, if the person has a farm that grows coffee, let them know about me. Try to put them in contact with me, because my goal this year, that is starting, one of my wishes, is to find collaboration and new partners that can work with me in this huge challenge that I decided to accept, that I created, which is to build the fingerprint of coffee consumption. Okay, my friends, I'm going to leave you now, and I'll see you next Saturday around 4 o'clock, like we've been doing. And I hope you have a wonderful week, a great Sunday, and see you soon.